Oh, whoops. Okay, hello. So the remainder theorem. Fine. Let's see. So consider, I don't know why this is B then A. That's silly. Okay, but anyways, consider the polynomial x cubed plus x squared minus 4x plus 41. We need to divide the function by x plus 4. So let's do that. We're just going to use synthetic division because we know how to do that now, and we can do it because it's just an x. Bring down the 1. 1 times negative 4, negative 3, 12, 8, negative 32, and 9. Remember, you multiply, add. Multiply, add. Multiply, add. So then that x cubed plus x squared minus 4x plus 41 divided by x plus 4 is x squared minus 3x plus 8 plus 9 over x plus 4. Let's also find f of negative 4. So we're just going to plug negative 4 in for wherever the x's are, put that whole thing into the calculator, and we get 9. See if you notice anything between a and b right there. They have the same remainders, okay? Let's do it one more time. So we're going to divide by 9, or x minus 9. And we have 7, negative 63, 0 because there wasn't an x squared, 9 and negative 80. Bring down the 7. 7 times 9 is 63. Negative 63 plus 63 is 0. 0 times 9 is 0. 0 plus 0 is 0. 0 times 9 is 0. 9 plus 0 is 9. 9 times 9 is 81. And negative 80 plus 81 is 1. So then that's going to be 7x cubed. We don't have an x squared. We don't have an x. So plus 9 plus 1 over x minus 9. And let's also find f of 9. So that's going to be 7 times 9 to the 4th minus 63 times 9 cubed plus 9 times 9 minus 81, and that equals 1. Those are the same, and those are the same. So if you ever need to figure out the remainder of something, you can just plug in that number. So plug in 9 or plug in negative 4. It's always the opposite of what this is, and that will give you the remainder. If it comes out to be 0, say that this came out to be 0, then that would have meant that x minus 9 was a factor. Okay, but since it came out to be 1, it is not a factor. X minus 9 is not a factor of that. Okay? Let's see. So the remainder theorem, if a polynomial function f of x is divided by x minus c, then the remainder is f of c. Using synthetic division to evaluate a function is called synthetic substitution. Neato. All right. Use the remainder theorem to evaluate f of x at c. So there's two ways to do this, and I only did it one way. I'm going to show you both ways, just bear with me. So first, let's just use synthetic division. So 1, 8, 12, negative 7, negative 14. And we're dividing by negative 3. So bring down that 1. 1 times negative 3 is negative 3. 8 times negative 3 is 5. 5 times negative 3 is negative 15. Add that negative 3. Negative 3 times negative 3 is 9. 2 times negative 3 is negative 6. Negative 20. So that means that f of negative 3 equals negative 20. Now, this is totally up to you, whatever you want to do. This is what we were trying to find out. From the last example, we know that we can just plug in negative 3 to this, so f of negative 3. And that would equal negative 3 to the 4th plus 8 times negative 3 cubed plus blah, 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 blah. And that will equal negative 20. So if you want to do synthetic division, you're super awesome. If you want to do just plug this in, you're also super awesome because you get the same answer either way. Okay? You can do example D. You should get 11. Let's do example E. Again, I use synthetic division here. I'm just going to click through this real quick. And I get negative 360. And guess what? If you plug in negative 5 to this right here, you will also get negative 360. So you decide how you want to do that. If you want to do it by synthetic substitution, super awesome. If you want to do it where you just plug in negative 5 for the x's, also super awesome. Okay? You should do F, and that's what you should get, 2,498. Now this one. So the distance in feet that a person travels on a snowboard is modeled by the equation d of t equals 0.6 t squared plus 10t, where t is the time in seconds. And we're going to use the remainder theorem to find the distance traveled. So t is time in seconds, and we're finding the distance of 1 minute. So 1 minute equals 60 seconds. So I have 0.6, 10, and 0. I'm putting 60 on the outside because I want to know how far we traveled in 60 seconds. Bring down that 0.6, 36. 0.6 times 60 is 36. Add that, you get 46. 46 times 60 is 2,760. So D of 60 is 2,760 feet. So after 1 minute, a person on a snowboard travels 2,760 feet. The other way you could have done this is by plugging it in. I'm just going to check real quick. Yep, by plugging it in. So you could have done D of 60, 60 equals 0.6 times 60, squared, plus 10 times 60. Wow, I'm struggling. And that equals, you guessed it, there you go. Okay. Cool. And we knew this was feet because it was given to us right there. All right? Whoops. Let's do this one. So we're going to use the factor theorem to determine which binomials are factors of the given function. So we're going to use x plus 1 first. We can divide it. We have 1, 0, negative 31, and 30. Put negative 1 on the outside. So I'm bringing down the 1. 1 times negative 1 is negative 1. Negative 1. 1 times negative 1 times negative 1 is 1. Negative 31 plus 1 is negative 30. Add that, and you get 60. Now that remainder is not 0. So that is not a factor. It is only a factor if the remainder is 0. So now let's do 5. Use synthetic division. 1, 5, 5, 25, negative 6, negative 30, and 0. 0, so x minus 5 is a factor because our remainder there is 0. So it went in evenly. So that means that that is a factor. Now let's do negative 6, and I'm going to use the numbers from this right here, and I'm going to put them right there. You could just use this. It's going to work the same way, either way, okay? So then again, I'm going to bring down the 1. 1 times negative 6 is negative 6, negative 1, 6, 0. So our remainder is 0 again, which means x plus 6 is a factor. Okay, you can do example I. We'll also go over that one in class. So we're going to use the factor theorem and the given binomial to completely factor the function, then give the zeros. So first, we're going to use synthetic division to divide this. Bring down the 1. 1 times negative 3 is negative 3. 0. 0 times negative 3 is 0. Negative 4. Negative 4 times negative 3 is positive 12. And that's 0. So then that factors to x squared minus 0x minus 4, which that 0x isn't really helping us, so we can just get rid of it. x squared minus 4. So then that factors, this is a factor that we were already given, so we have to put it with it, and we have x squared minus 4 and x plus 3. Now, x squared minus 4 is a perfect square. X squared is a perfect square, 4 is a perfect square, which means that that is the difference of squares. So I can square root both sides, and I get x minus 2, x plus 2, and x plus 3. So that is the function completely factored. Then I have to give the zeros. So I have x minus 2 equals 0, x plus 2 equals 0, x plus 3 equals 0, which means x equals 2, x equals negative 2, and x equals negative 3. Cool? Let's do this one. So again, we're going to use synthetic division, and we're just going to divide all this out. I'm just clicking through it because we've done a million of these, and I think you get it by this point, or you should at least. So we have x squared plus 3x minus 4. Okay, now I'm going to bring down that x minus 5 factor, and I'm going to factor that x squared plus 3x minus 4. That factors to x plus 4, x minus 1. So this right here, is the completely factored version of f of x. Now we're finding the zeros. So x equals negative 4, positive 1, and positive 5. Save the next 2 examples for class, and remember to take the quiz, and I will see you when I see you. Bye. Have a good day. Goodbye. Stop.